Okay, let's look at the practice exam 3, problem number 9. Right? So we're going to use geometry to evaluate this definite integral. Right? First, we're going to try to rewrite this expression inside the square root. Right? So let's say 24 minus 2x minus x squared. Right? I'm gonna complete the square, so I'm gonna put the 24 as it is. Right? Then I'm gonna factor out the negative sign, so you have a negative, then you have a parenthesis, x squared. Right? And I'll pull out the negative sign from negative 2x, so that's going to be positive 2x. Right? Then I'm going to give a little bit of room here, then close the parenthesis. Alright, so in order to complete the square, we have x squared plus 2x, and so 1/2 of this number square, which is 1. It would be nice if we had 1 here, so I'm going to actually just go ahead and put 1 because we need this third term to complete the square. But this will change the function. So change the expression, so I'm gonna just subtract 1 right away. That way we're not changing the quantity. Right? So by combining, let's see, I like the 3 terms, so we're gonna keep them together and distribute this negative sign to this leftover term, negative 1. Right? So it's negative 1, so it's positive 1. Right, combine that with 24, so 24 plus 1, so that will be 25. Right? Then we're going to keep those 3 terms together, so you have x squared plus 2x plus 1. Right? And this is equal to, right, conveniently 25 is 5 squared. Right? Minus, right, quantity, so this is going to be just the x, half of 2, which is 1, so x plus 1 quantity squared. Right? So this definite integral can be written as integral from -6 to -1, and the square root of 5 squared minus quantity x plus 1 squared with respect to x. Right? So we need to be able to recognize this guy. Right? So let's look at the simpler version of that. Maybe we can recognize this. What if we had y equals square root of 5 squared minus x squared? Right? And this is going to be a semicircle, so an upper semicircle with radius 5. Right? So it's going to look like this. So here's the x-axis, and here is the y-axis. Right? It's centered at the origin, so upper semicircle, so it's going to look like this. Right, so somewhat like that. Then you see that here is the y-axis, that's the origin, and the radius is 5, so that's going to be 5 there, and that's going to be -5 there, and this is going to be +5 there. Alright, and the difference between this guy and what we are interested is right here, x plus 1 inside the parenthesis. Right? This is just the transformation. This is a shifting, actually adding 1. So it's going to shift the whole thing to the left by 1 unit. Right? So it's going to look like this. So instead of starting from 5, maybe -5, and it's going to actually go through -6. Right? And it's going to go through 4 there. Right? So the semicircle is shifted to the left by 1 unit, so it's going to look somewhat like that, right? Actually, that looks pretty bad, so I'll try my best. Right, so it's gonna look somewhat like that. Right, then you know, the integral is from -6 to -1, so -1 is going to be right in the middle. So here's -1. So we're looking at the region under the semicircle from -6 to -1. So we're looking at this region right here, -6 to -1. Right, so this is just a quarter disk, right, with the radius 5. So you can see that this is going to be, right, so this is going to be this area right here. So it's going to be a one quarter of the whole disk. So I'm gonna put the 1/4. Right, then the area of the whole disk would be pi radius squared. So pi, and the radius is, as we know, 5. So you have 5 squared. Right, so this will give you the area of the whole disk, but we take only 1/4 of that. Right, so therefore the integral, or the area, is 25 pi over 4. Right, so that's the value of the definite integral, which is the same as the area of this corresponding region. All right, that's it. I hope that this was clear.